Good morning, everybody. I think after I have to say a really exciting day yesterday. I hope that continues today with the noise factors TFG, and then hopefully with the discussions which Neil already mentioned. Now, from the noise factors perspective, let me give you a little bit of introduction, a little bit of background. So in all the AutoCFD, again, we need to keep in mind what the goal is. Yeah, we want to really do this. We are doing this workshop to really assess and improve the predictive capability for CFD codes for road car aerodynamics, and so that's our goal. And what we have seen in previous workshops is that we have a large scatter of results. Yeah, and that's certainly still a challenge, and we talked about this yesterday. And even if some of you are using very similar methods, yeah, using committee grids, using hybrid turbulence models, similar solver technologies, even if you use the same solver, yeah, you deliver results which are different. And that obviously creates some questions. Yeah, why is this? What is the root cause for these differences? And unfortunately, we have seen that some of them are relevant. It's not that just ignore them because it's so small. And what we have also seen, and specifically in AutoCFD3 and 4, when we started to use mean calc, is that from the statistical relevance standpoint, from the quality standpoint, not all the analysis fully satisfy what I would think is the requirement from an automotive OEM. And there's a bit of there's a difference. Yeah, we looked at the scatter, which you see upper right, and this scatter is like 50 counts. Yeah, so that's a challenge in itself. That's where we are discussing how that can be converge more in the future. If we talk noise factors, then we're talking a different thing. Yeah, we're talking now about 1, 2, 3 counts, and that still matters a lot. Yeah, because one of the main tasks for CFD in automotive industry is to help us design features on the vehicle. And then very often we have to make decisions. Is it worthwhile to invest in a front wheel deflector? If the front wheel deflector delivers 5 counts, we would perhaps say that's too expensive for 5 counts. If it would be 10 counts, we would perhaps say that's a good buy for the money we have to invest, and so let's do it. So we really look very closely, and I think sometimes I would say in our case, and perhaps later on others can comment on this, we try to make decisions based on CFD when we're talking about 2 counts. We would say, hey, that's these 2 counts, let's do this design change, it's worth 2 counts, let's go for it. And so having uncertainty in the range of 2 counts is not very helpful. So I think, so there are two challenges here. One is this overall high-level prediction capability with this big spread, which we are still seeing, where we're working on, but then being aware of the noise factor, which is also present, is important, and we try to create this awareness. So generally speaking, if I would show my boss this big scatter, he would look at me and say, why the heck are we doing CFD 50 counts up and down with all these methods? That's almost useless. And my answer would be, we do have very well-defined best practices, which very clearly define how we are doing our analysis. And if we apply these best practices in a very consistent fashion, we'll not see the spread. I'm not saying that we get everything right. That's not a statement, but certainly we're going to reduce the spread a lot. And what we are doing in these best practices, we have a selected solver. We're not changing solvers all the time. We have a way how we design our volume measures with refinement boxes, like Vangelis showed before. We have a turbulence model of choice we are looking at, we are using in the day-to-day production, and we have a certain solving strategy, like initialization process and this kind of stuff. So with that, we certainly reduce the variability of our results. And then also, I think one other aspect which is important is this aspect of how long we are running and how we are averaging. That is, we talked about mean calc and how it helps us to understand the variability of results. So having a really controlled process, how to define the start time for averaging, the length of the averaging is critical to reduce again the variability of your results. If we're talking about noise factors, and I think it was AutoCFD4 when I started to talk a little bit to participants about this, and I got a few people looking at me and saying, "What the heck are you talking about?" For example, when I said, "Hey, if I run this on an AMD chip versus an Intel chip, I'm getting 3 counts different results." Why could that ever be? But it's what it is. That's what we have seen. Absolutely, certainly. Not just a question if you go from CPU to GPU, where this question has been discussed yesterday by, I think, for example, Dassault and others. So everybody's looking at this. But we have certainly seen it just from going from one CPU type to the other one. Certainly, one I think better known problem is the partitioning. If you decide to run your job on 500 versus 1,000 CPUs, it makes a difference. Sometimes you in engineering you get this pressure. I need this answer faster, and rather than using 500, which is perhaps your standard, you say, okay, I'm going for 1,000 and run this job on 1,000. But you're looking for an answer of what is the impact of this small design change, and then all of a sudden your result is not comparable anymore because you're introducing another noise factor because your partitioning has changed. We have also seen things like you have let's talk driveware. We have this ANSA model which has this nice PID structure of the parts in the driveware, and you decide to make the first part in the ANSA structure, make it the last part. No change, no mesh change, no nothing. It's just different structure. So I guess later on the solver or the mesher reads the file in a different order and stuff like this. And it's a difference. It's all of a sudden you have thousands of volume cells difference between the two meshes you created, and at the end there's a count or two different in rack. And then minor, we had a very interesting presentation at the beginning of the TFG where we have seen there's this huge domain. And somebody decided at the outlet of the domain to just add another 8 cells for, what is it, 150 million. 8 at the outlet. 2-3 counts difference and the results. And so all these kind of things, they are real, they happen. And so I think that created this interest to do this noise factor TFG and investigate this a bit more. As I said, I already mentioned, we are looking at deltas of 1 count, 2 counts. So if noise factors are in this range, they become relevant, and that's something we want to create this awareness also for researchers and software developers that we have to pay attention to these things. And while we're doing this investigation here, obviously we have to use the same principles like we use in the automotive industry. You need strict application of a best practice method. You can only investigate one noise factor at a time, otherwise you have all kind of overlaying effects which you would not understand anymore. Yeah, let me just, this was our kind of the one pager we created. I've mentioned most of it. Let me just quickly again talk about the goals. So first of all, our goal was to improve the understanding of these noise factors. As I said, not everybody was very aware of the relevance of these noise factors. We would like to create an overview, and you will see that overview in a minute. And hopefully, as I said, we hopefully can provide some input and guidance to software vendors and researchers so that they perhaps can spend a bit more time and perhaps help us to reduce the impact of these noise factors. I think at this stage, I would say we have not yet achieved the goal of being able to understand how noise factor differ from code to code. There's a chance that they do because of however codes are designed. I guess there is a good chance that there might be a difference. I think we have not yet had enough opportunity to do these comparisons, but that can be a goal for the future. And then certainly we all would like to minimize these noise factors. And again, that is not something we have been able to do yet. My last slide before I let all the people talk about the work they have done is we started with this overview. You see on the top, you see a number of different noise factors. I mentioned most of them. And then you see on the left side, you see on the right side, you see the participants. We always had really good participation in our meeting. There was always a good number of people which actively participated and contributed. and they're all kind of different studies, as you can see here. So there was a lot of work was done, many analysis, and already I marked a few here, and the ones which are still shown in white, that is stuff you already saw yesterday. I think Eugen talked about investigation C conducted yesterday. We had Guido talking about pieces, and I will most likely, we will have an opportunity to continue his talk a little bit at the end of our session. And Niels talked a little bit about work done at Ford for noise factors, and which was then in cooperation with Vangelis. So today we'll hear more from Siemens, from Bramble, from the Ohio State University, from Skoda, and again from Ford. So that hopefully should give some more insight in the relevance of the noise factors. I think that's my introduction. I have one last slide where I leave for the summary at the end. But with this, I would suggest we start with the first talk. Thank you very much. You saw that slide before. I guess you got an impression of the huge amount of work which the team did. And this is, as I said, just a small part. You see the dots at the bottom. The list is much longer. What I tried to do on the only slide I want to share with you here is I tried to summarize all of this. Yeah, you have seen these categories of noise factors before, and we just lumped these investigations together, and the maximum deltas we have seen are shown here. So it should give you a bit of an impression. Yeah, I don't think the data is yet complete enough to be sure that that is fully representative. Like, for example, at the moment you see zeros on the CPU type. We haven't had many contributions on this one. I can tell you, I've definitely seen it. It's not zero. So I think there will be more data coming in, hopefully, if we continue with this workshop. But it should give you a bit of an impression of where we are. You see these 4 counts, 1 count, 2.5 counts, 4 counts, 2 counts, and you got all the messages. And I think some of the data which got presented here today is not even included. So what I plan to do is to ensure that that's updated, and then we're going to share this with the community just as a bit of a reference and reminder. And I think this session and the TFG hopefully has helped to improve the understanding of the noise factors and have confirmed how important they are, and have also provided a bit of a quantification. Again, not yet fully conclusive, I would say, but nevertheless, I think already giving a lot of indications. I think important remains to be the fact that everybody needs to properly ensure that the analysis carried out are long enough and fulfill criteria like those which we can check with mean calc. I think specifically the noise factor group has paid much attention to this. We heard about the Skoda team who ran very long. We heard Paul Norman talking about he has used mean calc to ensure that all the results are statistically relevant. So I think that needs to continue. We need to ensure that there is good relevance. What we have not yet done, and that's still ahead of us, is really to see, are there ways to reduce this, the noise factors? Is there anything we can do on the software development side, on the best practice side? And we have also not yet looked into the question of, is there a difference between different codes, between solver technologies? Are some more vulnerable to this compared to others? I think that's still something we want to do. I think one statement is still important. Skoda made the statement before, and I can just repeat this. We have certainly seen real-world application cases with full complex geometries, with even more complex meshes, where these noise factors are even larger. So this is almost a kind of, shouldn't call it best case, but there are definitely cases where these things can get quite a bit worse. And I hope everybody has recognized that has great relevance. With that, we're at the end of the session. Again, thank you very much for everybody who contributed to the TFG. Great work, and for all the great presentations. Thank you.